Bismillahirrahmanirrahim. Today, inshallah, I wanted to acquaint ourselves with terminology that is affiliated or associated with the hyperbola. In doing so, we're going to review the terminology that is associated with an ellipse and extrapolate and build on that. If you recall, an ellipse has two vertices, or major vertices, or just plain vertices, and they are located on the major axis of an ellipse. Okay, so an ellipse has this axis over here, and that's called a major axis, and that's the axis that has the vertices. Okay, and then an ellipse, if you also recall, has a minor axis, and that's where the co-vertices are present. Okay, so those are the co-vertices, major and minor axis. Now, if you also recall, the minor axis was over here, and the length from the center of the ellipse to one of those co-vertices, that was B, and the length from the center of the ellipse to one of the vertices, that was A. Okay, and then also, if you recall, an ellipse had foci. Here's one foci, and here's the second foci. It has two foci, and that's what or used to define the ellipse. Okay, and the distance from the center to the foci, that was C, and the relationship between A and B and C was like this. Okay, now if you recall, the way I remember this was, okay, this is A, okay, and the foci was somewhere here, so that was C, and then the B was over here. Okay, so A was the longest side, so the relationship was, okay, C squared plus B squared was A squared. Okay, so this plus this was this squared. We should make a triangle out of it. And then you can solve this for C. C squared was equal to A squared minus B squared. And that was the relationship between the A, B, and C for an ellipse. Okay, and I don't really memorize these. I like to derive it in that way. So C squared was A squared minus B squared. Okay, so the two foci, the major axis, minor axis, and if you say major axis was the 2 times the length of A, and the minor axis was 2 times the length of B. Okay, so now to draw a hyperbola, we have to make this rectangle. Okay, this rectangle right here. This rectangle actually does not have a name to it, so I thought we could just invent a name, and let's call this the hyperbolic rectangle. Hyperbolic rectangle. Now the thing about this is it could be a rectangle or it could be a square. In other words, you could make it a hyperbola with putting the square here. I'm trying to make a square here. Okay, and then you draw these asymptotes like this. Now that's a square, and then you can draw a hyperbola like this. Okay, so it doesn't have to be a rectangle. So our hyperbolic rectangle could be a square, but a square, we would say, poetically, is just a type of a rectangle. Okay, so that's very important, because that's kind of like what you have to do to graph the hyperbolas. Okay, now the center of this rectangle is where the two asymptotes intersect. So the hyperbola has asymptotes. So here's an asymptote, and then here's the other asymptote over there. And the center of these two is going to be, we're going to call that right here, that's the center. Okay, so the center for us is the pseudovertex. Okay, the center is the pseudovertex. All right. And from the center, okay, from the center to the actual vertex here, okay, right here, that is A. Okay, now in this case, so this is actually the vertex of the parabola, of the hyperbola. It has two vertices. There's one over there, and there's one over here. Let me write the vertex over, just the vertex. Okay, so those are the two vertices. It has two vertices. Okay, two vertex or vertices. And from here, from the center or the pseudo vertex to this end of the rectangle, the hyperbolic, right? That's the B. Okay, you follow? So this from here to here is A, and from here to here is B. Okay, now you can't call there's no major axis and minor axis when you talk about hyperbola, because as I said, major and minor axis is a terminology that refers to ellipses, and that's not transferable to hyperbola, because major and minor axis, so to speak, can be equal for a hyperbola. You can make a hyperbola out of a square, so it doesn't make sense to call something major and minor if they're both equal in length. Okay, so this terminology does not transfer. But what you do call, but what you do call from here to here, there is a term that refers to that, okay, and then there is a term that refers to this, okay. So those are given names. I'm going to highlight those for you. Now, it does help to not know these, okay, because, you know, there's a lot of terms here, right? But, you know, it's just, they're not bad. We can do it. Okay, so this length, which is 2 times the A, okay, that's called the transverse axis. And this axis, which is 2 times B, the whole length, the width in this case of the rectangle, the hyperbolic rectangle, is called the conjugate axis. Okay, so the conjugate axis, okay, or conjugate segments. So transverse axis and the conjugate axis. Okay, now a hyperbola also has foci, okay, and we're going to talk about those. And the foci are going to be on the outside. They're not going to be in here, okay, because they're going to be on the outside over here. And the relationship between A, B, and C in this case is actually straightforward. A squared plus B squared is going to equal to C squared. Okay, so 25 plus 9 is 34. C is the square root. In this case, I'm just doing this for you, square root of 34. Okay, so which is 5.83 about. Okay, so that's like over here, the foci. So the foci are on the outside over here, and they're going to be like C and 0, and then negative C and 0 in this case over here. Okay, so C here is the distance from the center to the foci right there. That is C. Okay, now there's a lot of terminology here, right? So let's just review this, and we shall elaborate on this inshallah next time. So let's review what we learned. We compared our understanding of hyperbolas to ellipses. An ellipsis has major axis and a minor axis, and the two vertices of the ellipse are located on the major axis always, and the two co-vertices are on the minor axis of an ellipse. The distance from the center or the pseudo-vertex of an ellipse to the vertex, that's A, from the center to the co-vertex is B. And the relationship between A, B, and C, C being the distance from the center to the foci, is C equals A squared minus B squared. As you recall, I don't memorize those. I just try to imagine that this is a triangle, C and B, and then this would be like A, and then A is the hypotenuse in that case, okay, so of that triangle. So that's the relationship there. And then we kind of extrapolated that knowledge over here. And I said to draw a hyperbola, you have to have this rectangle. And I suggested, as far as I know, there might be actually, but there is no term associated with the rectangle, so I invented one. We should call this the hyperbolic rectangle. And I suggested also it could be a square as well. In that case, you can call it a hyperbolic square, whatever. But a square is a special type of rectangle. So we shall use this affectionate terminology, hyperbolic rectangle. The center of the hyperbolic rectangle, where the two of these asymptotes meet, that is the center of the hyperbola. That's the official term. Affectionately, we shall call that the pseudovertex, the Vx and Vy. An ellipse has hyperbola has a proper vertices, and they are here. And it has two vertices. And the ordered pair that corresponds to the vertices are related to the center, and a distance from the center on either side. And those are the vertices. Now, a hyperbola also has two foci, okay? And the distance from the center to the foci is c, and the relationship between a, b, and c is thus, okay? And that's reasonably easy. The way I remember this is because c is always the longest. You take the two smaller side, you try to invent a Pythagorean theorem out of it. So in this case, a squared plus b squared is going to be c squared over here, if you'll observe this little triangle over here. Okay, so that is the terminology that is associated with the hyperbola, and inshallah we shall elaborate on this in the future and learn more about it. Until then, as-salatu was-salamu ala rasulillah. Assalamu alaikum.